Okay, solving linear equations. With some of these, we'll have some quadratics in them somehow. So let's start with an easier type of problem. If you're asked to solve this, I can think of two quick ways to do that. First is you can think of this as 3 over 1, and then you basically have two ratios or a proportion, and you should be able to solve that by cross multiplying. So you can do 4 times 1 equals 3 times x plus 2. So it ends up being 4 is 3x plus 6. Take the 6 away. Negative 2 is equal to 3x. So divide by 3. So you get an answer negative 2 over 3. So that would be one way to solve it. I can do the same problem a different way. And that would be to look at this x plus 2, realize that that really is a fraction, and I don't really like fractions. So I'm going to multiply by x plus 2 on both sides. Okay, so when I do that, this x plus 2 cancels. That's a 4. And on the other side, you get 3 times x plus 2. And then you obviously end up with the same problem. And we should get the same answer, which we do. So that would be one type that you might see, or that you will see in your homework. There's some other problems that you should be able to do. And they initially look like quadratics, so they'll have a square in them, but sort of a fake quadratic. So this one's already set up for you to cross multiply. So I'm going to do x times x on one side, and x minus 2 times x plus 1 on the other side. So this is an x squared, and x times x is x squared, plus 1x minus 2x minus 2. So we get x squared is equal to x squared minus x minus 2. Well, these cancel each other out. That does leave a 0. Move the x across by adding, so you get x equals a negative 2. Especially on fractions, and I should have done that here as well, you do need to check to make sure that this answer works. So if you plug in a negative 2, you get a negative 2, negative 2 minus 2. What we're really concerned about is what happens over here. Okay, that ends up being a negative 2 over negative 4, which is okay. And the same thing happens over here. What happens over here? Okay. And think about that. What is the problem with fractions, or what is a problem that you sometimes run into with fractions? So a negative 2 plus 1 is a negative 1. Hopefully, you've thought about that for a second then. And the problem with fractions is if you have a 0 here. In this case, we don't have any problems, and we end up with two fractions that are worth the same. So it worked. We'll do one more of those. That over here. And I should have enough room, I think. Okay. So same thing. So you get a plus 2 as a factor times a minus 4. So a plus 2, a minus 4. And a minus 3 times a plus 4. And a minus 3 times a plus 4. And so the same thing happens here. You FOIL this, so we get a squared minus 4a plus 2a minus 8 equals a squared plus 4a minus 3a minus 12. So a squared and a squared cancels. Now a negative 4a and a positive 4a aren't going to cancel like this because they don't have the same sign. So don't do that. You probably should simplify here anyway, and that will help you avoid that mistake a little bit. So you get a negative 2a here, and 4 minus 3 is 1a minus 12. I like working with positive variables, so I'm going to add 2a on both sides. So that makes this 3a, which means I should have added 12 on both sides to move the 12 across. So did I cancel? Yep. So you get 4, and the answer then will be 4 divided by 3 is equal to a. And I'm going to do the same thing. I'm not going to work the whole thing out. I'm just going to check my denominators here. So if I plugged in 4 over 3 for a, do I get a 0 here? so I don't, so I feel pretty good about that one. And on the other side, when you plug in 4 over 3 and do minus 4, you also don't get 0. So this should work. Alright, thanks.